Before we get started with actually working with sequence and series, let's quickly go through some of the common vocabulary words and phrases. So the first thing we'll take a look at is this word terms. We've seen it before, and usually it means when things are added together we call them terms. Here in sequences and series, any items that are in a list are called terms, and they could be numbers or they could be monomials. If you don't remember what monomials are, you should probably go back and look that up. Now that we know what terms are, we can talk about sequences. A sequence is simply a list of terms, and usually all of the terms in a sequence are separated by commas. Another thing that involves terms is something called a series. A series is also a list of terms, just like a sequence, but in a series, all of the terms are added together. Now, we have different types of sequences and series. We're going to look at two different types in this chapter. One of them is called arithmetic, and you can have arithmetic sequences or series. And the thing that defines an arithmetic sequence or series is that you add a fixed value to get from one term to the next. Let's contrast and compare that with something called a geometric sequence or series. In a geometric sequence or series, to get from one term to the next, you will multiply by a fixed value. That's different than adding a fixed value, and we'll see that in examples. Now, when we look through material that discusses sequences and series, there will usually be a phrase, the common difference. And that's usually abbreviated with just a lowercase d. Common difference is usually just d, like that. And the common difference, the definition is, it's the difference between a term and the previous term in an arithmetic sequence or series. In fact, the common difference is the thing that defines an arithmetic sequence or series. If you have terms, if you have a list of terms, and the difference between any two terms is the same, then we will call it an arithmetic sequence. Now, I need to remind you what the definition of difference is. Remember, difference means the result of a subtraction. So when we say difference, we mean the result of a subtraction. Now, let's compare this with this other frequently used phrase in sequences and series, the common ratio. Common ratio is associated with a geometric sequence or series. You get a common ratio by taking the quotient of a term and the previous term. And the common ratio is normally abbreviated with a lowercase r. So common difference is lowercase d, common ratio is lowercase r, and now you have all the definitions. Now let's go and see what we can do with these guys. So let's first start off by examining an arithmetic series. Now from this point forward, I'm going to talk very little about sequences because series and sequences are almost the same thing. But series have this magical additional concept that you can get a sum as well as having a bunch of terms. So anyways, so we're mainly going to focus on series, but we still might be interested in finding a particular term in a series, just like we would with a sequence. So we'll do that with series instead of with sequences. So anyways, with an arithmetic series, notice that there is a common difference between any two terms. In this case, if I did negative 60 minus negative 66, I believe, let's see here, we're adding 6 each time. So negative 60 minus negative 66 would be positive 6. And then negative 66 minus negative 72, again, that would be positive 6. So in this particular case, our common difference, which is abbreviated with a little d, that would be 6. And the way that we found it, just in case you're interested, is we would take a term and then subtract the previous term. So negative 66 minus negative 72. Let's clean that up a little bit. Negative 72. And that is the same as negative 66 plus 72, and that gets us positive 6. So that gets us our common difference. The other thing that's interesting about this series is the very first term. The first term in the series, in this particular case, is negative 78, and it has a special symbol. In fact, actually, I'm going to write out all the symbols for you. Normally, when we refer to to terms in a series or a sequence, we refer to the first term as a sub 1, and the second term is a sub 2, and the third term is a sub 3, and so on and so forth, a sub 4, and then we could keep going, dot, 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 all the way out to any number of terms. And we'll just call a particular term of interest, we'll call it a sub n. In other words, this will be the nth term. We don't know whether it's the 7th or the 134th, but it is a term. Now, notice that 78 has a special symbol that's associated with it. It is the first term, and the first term is always going to be a sub 1. That's important. And again, this term of interest, the term that we might like to find, this will always be a sub n, and that's known as the nth term. Now, if we know d and we know a sub 1, it turns out that there is a handy-dandy formula which helps us to find the nth term. Now that I've written out the formula for the nth term, which is this guy right here, I want to point out there's one extra little thing that I didn't mention yet, and that's this thing n right here. So let's take a look. Let's take a look and see what n is. N is just the number of the term that you're interested in. So if I'm interested in the first term, then n would be 1. If I'm interested in the second term, then n would be 2. If I'm interested in the third term, n would be 3. Now, in a second, we'll do a quick example just to see what I mean. So let's do a quick example where we find the 43rd term for this given arithmetic series. So first of all, let's gather up the stuff that we need. We're looking for the 43rd term, so we're looking for a sub 43. So let's put in parentheses, this is what we want, a sub 43. We sort of want the nth term, but we happen to know that n equals 43, and now I'm giving that away. A sub 43 means that n is going to equal 43. And then our first term is negative 78, so a sub 1 equals negative 78. And the only other thing is d, and we figured out that was 6, so d equals 6. And from that, we can now go ahead and figure out that a sub 43 must be equal to a sub 1, which is negative 78, and we'll add that to n minus 1, which is going to be 42. And then times d, which is 6. And if we do the math, that turns out to be, oh, you know, before I give you the number, why don't you pause the video for a moment and double check and make sure you can repeat this calculation yourself and get the correct answer. Okay, so the number I came up with is 174. So that's the 43rd term in the given arithmetic series. Now, notice that's not that exciting because all we're finding is a term in the series. But when we have a series, that means stuff's being added together. So something we can look at that's a little bit more interesting is maybe we can look at the sum of the series. That'll be cool.